So you are saying ether channel is a technology which is used to bundle multiple physical link into single logical link. Why we
Yes,
need to
sir.
bundle the multiple physical link, by the way? What is the need of bundling the link? You are saying that ether channel is used to bundle, let's say, this two link over here and this two link over here. I am asking you why it is required, why we need to bundle these two link.
So to provide some redundancy, for example, if we making four interface in single logical link, out of two went down, so rest of the two will carry the traffic from one switch to another.
Okay, if we have only two link between switch 1 and switch 2, then we have already redundancy. One path is backup path and switch is using one path for data forwarding. So we are using only one path, one link between switch 1 and switch 2. Yes or no? Because of a
Yes, sir.
spanning tree.
Yes, sir.
A spanning tree will block which port on which switch. If switch 1 is switch 1 MAC address is 0A and switch 2 MAC address is 0B. Let's suppose, and here if you want to see the MAC address, how I can check base MAC address of switch? How can I check base MAC address of this switch?
Show inventory.
So
For inventory, show system.
in so version we are able to see base Ethernet MAC address is this one. So this is the MAC address of switch 1. This is MAC address of switch 1. What is happening in Pent? Oh, this is MAC address of switch 1. And if I will show you MAC address of switch 2, so version, this is MAC address of switch 2. Now tell me which switch will become root bridge.
Switch one.
Switch 1 will become root bridge or switch 2? According to me, switch 2 will become root bridge. Because switch 2 have lower MAC address and by default priority is same on both switches. But I want switch 1 should be the root bridge. So I need to configure lower priority there. So on switch number 1 I am going to configure lower priority. What is the command? A spanning tree for VLAN 124094 and priority 0. So now switch 1 will become root bridge for all VLAN. Okay, we can verify it. So a spanning tree protocol. Both ports are DP and here we are able to see this bridge is the root. And on switch number 2, if I will run so a spanning tree, so you can see 0/20 port is alternate port and state is blocking. So between switch 1 and switch 2, let's say this link, upper link have bandwidth of 100 Mbps and lower link bandwidth is also 100 Mbps. Both link bandwidth is 100 Mbps. So between switch 1 and switch 2, total throughput is 400 Mbps. But we are using only 200 Mbps because of a spanning tree protocol. So if you want to utilize both link 0/19 as well as 20, you have one technology that is called ether channel. Through ether channel we can bundle this link, and by bundling we will create one logical link, and a spanning tree protocol will work on that logical link, not on physical link. Let's say this is my logical link, so now on this link a spanning tree protocol will work. right? Then guys, if we are using both link 0/19 and 20 between switch 1 and switch 2, can anyone explain how loop will not form then? Because again, topology is, by the way, we have two link, virtually we have one link, but switch will forward the traffic from the physical link only. Then how loop cannot form? Is it possible that here we have bundled these two links, and here also we have bundled these two links? Here we have created port channel 10 and let's say port channel 10, and now one PC is generating one broadcast message towards switch 1. This is a broadcast frame. So switch 1 will forward this broadcast frame from both of these two interface, yes or no? Yes, it should forward it from both interface. Am I right? Or it will forward from only one interface? Will switch 1 forward broadcast message from both interface or from single interface?
From both, sir.
From both. Then when switch 2 will receive broadcast message over here, that broadcast message will be sent from this interface as well, yes or no?
Yes.
Then again loop, there is loop. Switch 1 is receiving same broadcast message which switch 1 is sending to switch 2. Then again we have loop in the topology. So anyone have answer, yes or no?
No, switch will consider it a single interface.
Hmm? Your voice is very low, brother. Can you speak again?
Switch will consider it a single interface.
It will forward from
These
single
two interface
interface.
combined.
No, if message is broadcast, then it will forward from both interface.
When we will combine two interfaces, physical
Okay.
interfaces, single logical interface, then switch will detect that this is switch will consider it a single interface.
Switch 2 or switch 1?
Switch 2.
Switch 2. Yes. Switch 1 will forward broadcast message from both interface, but when switch 2 will receive the broadcast message, it will check, okay, I am receiving a message, a frame on this interface, and this interface is member of port channel 10. So I will not forward this broadcast message from the any port which are member of same port channel. So it will not forward this broadcast message from this interface, because this interface is also member of same port channel. Concept is, whenever switch 2, like in this scenario, switch 1 will forward broadcast message on both interface, but when switch 2 will receive the broadcast message on this interface, it will not forward that broadcast message from this other interface 0/20, because it is switch 2 will check that I am receiving, my receiving interface is member of which port channel. So port channel 10, so I will not forward that broadcast message from any port which is member of same port channel. This is how loop will not form. Is it clear? Now how many link I can bundle through ether channel? How many link we can bundle through ether channel? Any number? R1 and R2. Before configuring R1 and R2, I am going to bundle these two links through Ether channel. So command is very simple to configure Ether channel or to create port channel. First of all, recommendation is whenever you are bundling multiple physical link, so you should shut down those interface, right? Like I am going to bundle 0/90 and 20 together, so these two interface should be shut down before bundling it, right? This is just a recommendation. You will not face any problem if you will shut down the port first. So interface range f1/0/19 to 20, 0/90 to 20, then channel group, after that channel group number. Guys, this number is locally significant or it should be same on both switch. Yes, Nirav?
It should same.
No, it is locally significant. It
You
can be
got it.
same or it can be different also. We can create channel group 10 over here. We can create channel group 10, 20 on switch number 2. We don't have any problem. Then we have mode. We will discuss about this mode. Now I am going to use on mode. Fine. And how to verify it? So IP interface brief, this is the first command. In this command you will see your port channel 10 is created over here, and here we don't have any IP address, right? And this is up and up, line protocol is up as well as status is up. Okay, in the same way on switch number 2 also I am going to configure channel group. Interface range f1/0/19 to 20, and channel group here I am going to create channel group 20 and mode is on. And so IP interface brief. Here also you can see port channel 20 has been created and status is up, line protocol is up. This is the first command. Or we can run command like show interface port channel and then port channel number 20 like P20, line protocol and status both are up. Okay, this is the first command. Second command is if you want to check how many interfaces you have bundle in this port channel, you can run command show ether channel summary. This command will show you the ports, like you can see 0/19 and 0/20 is bundled in port channel group 10. We will discuss about these words later, but here we have bundle the link. And now if you will check show a spanning tree, so you can see a spanning tree is working on port channel 10. Earlier a spanning tree protocol was working on 0/19 and 20, but now a spanning tree is working on port channel. On switch number 2 also show a spanning tree. Fine. That means we are now using both links 0/19 as well as 20 between switch 1 and switch 2. Now on switch number 1 I am going to do one thing. Just I want to show you that whenever switch will receive a broadcast message, it will forward from both interface or from a single interface. For that I can check packet out interface. So interface fast Ethernet 1/0/19, and broadcast message we cannot check like this. We can capture the link in GN in EVNG, because here if it will send one broadcast message, right? It is sending actually lots of messages on the link like CDP message, VTP message, so it is difficult to identify which message is the message of broadcast. So that's why I'm not going to use this method for now. But if switch 1 will receive broadcast message, it will forward from both interface 0/90 and 0/20, right? When switch 2 will receive, right, when switch 2 will receive the broadcast message on which interface? It will receive on any interface. It will receive on both interface. Maybe it is receiving first on 0/19. So it will check so ether channel summary, and it will find that 0/19 and 0/20 are member of same port channel. So whatever broadcast message it will receive on this port, it will not forward from this port, or whatever message it will receive on this port, it will not forward from this port. Okay, this is just a basic configuration of ether channel. After that, we have some more troubleshooting command, verification command, like we can check so ether channel, and after that see the question mark, port channel group number, and then we have detail option, so we can check detailed information of port channel configuration on all ports. Like if I will hit enter over here, you can see we have detailed information about this port 0/20. In the same way, here I have detailed information about 0/19, like which protocol I am using. Now I am not using any protocol, this is a static method, so that's why we are not able to see any protocol here. But mode is on, that mode we are using now is on mode on this interface, and 0/20 also mode is on, we don't have any protocol. Then we can check the channel group number, right, port channel. These are the information inside the command of this command, output of this command. After that, we can use here load balancing. Like I want to check load balancing algorithm, so by default the load balancing algorithm which is running on switch is source MAC address, right? We will discuss about this also later. Then show ether channel, and so ether channel summary we already discussed it. By using protocol, we can check the protocol, which protocol we are using. After that, this is the detailed command, we already discussed this. These are some verification command that we are going to use in upcoming, maybe in next video or today later. Okay, so till here everything is clear to all? Is everything clear till here to all? Tell me guys if anyone have any confusion, any dot, that why we come up with ether channel, how loop will not form in ether channel, how a spanning tree protocol will work over ether channel. hmm. Nirav, is it clear? Mohan?
Sir, say for example, if third switch is connected and all three switches have similar port channel, ether channel
Okay,
between every three switches, each of the three switches.
have same port channel group number.
No, 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 no. If it is in a triangle form, if
Okay,
switch 1, switch 2, switch 3, uh, initially we had single connectivity. Then if we have this port channel, ether channel between all three switches, then the same STP will apply on ether port channel, correct?
correct,
Same rule.
correct, correct. In fact, if between, let's say, switch 1 and switch 2 I have two more link, okay, and we have bundle upper two link in one port channel and up lower two link in other port channel, so a spanning tree is going to block one of port channel.
Okay.
Okay, here a spanning tree
Yes.
will block one port channel. Okay,
Okay, sir.
anything else? Now guys, there is some requirement of ether channel. Whenever you are bundling, let's say 4 link or 8 link or 2 link, doesn't matter how many link you are bundling. Whenever you are bundling, there is some requirement, like a speed of all links should be same. Here on switch number 1 we have bundle 0/19 and 0/20, and by default speed is so IP interface f1/0/19. So interface f1/0/19. Speed is speed is bandwidth is 100 Mbps. Speed of this link is 100 Mbps. So speed should be same on both link. If I will change the speed of one link, let's say a speed of 0/19 is 90 Mbps and a speed of lower link 0/20 is 100 Mbps, then again ether channel is not going to work properly. Interface f1/0/19, and here I am going to say bandwidth, let's say 900 Mbps or 90 Mbps. Fine, and just wait. So interface range f1/0/19 to 20 and say shutdown, and then say no shutdown. So IP interface brief. My port channel is still up. So ether channel summary. Port channel is still up. You will get one log message soon. So interface f1/0/19. Let me do one thing. Interface range f1/0/19 to 20 and say no channel group 10 mode is okay. Channel group 10 is still there, but there is no any interface. Now I am going to again bundle, let's say 1/90 to 20 and channel group number is 20, let's say mode is on. So IP interface P20. Line protocol is up and status is also up. Interface 1/0/19 duplex up. Still ether channel is up. Fast Ethernet 1/0/20 is not compatible with Fast Ethernet 1/0/19 and will be suspended. Okay, so now if you will run command show ether channel summary here, you can see 0/1/0/20 is suspended. S4 suspend. Small s, capital S means layer 2. Okay, in the same way speed is also required. Actually we are changing the bandwidth. Because of bandwidth it is not working, but this is also the requirement that speed should be same. So interface f1/0/19, here we have changed the bandwidth. I am going to remove this command. Say no bandwidth again. Bandwidth is 100 Mbps, that is fine, and ether channel is not working. So because second requirement is duplex should be same, and now duplex is not same on both interface. So because of that my ether channel is so IP interface P20. My ether channel is up, but 0/20 is suspended. Ether channel is up, but ether channel will not work properly over here on switch, is not working properly on switch number 1. One port is suspended. How we can verify? So ether channel summary, this port is suspended, and here we have one more command. So ether channel, and we can run protocol. So we already discussed protocol mode is on. So ether channel, so with the help of this command we are able to see ether channel group state. Group state is layer 2. Maximum port that we can bundle is 8. In case of static method, when you are using on mode, then you can bundle up to 8 link. Okay, and now how many link is bundled? One link is suspended, that's why it is showing you only one. Fine, these are the information here. Again I am going to set same duplex on fast ethernet 1/0/19, say duplex and full duplex, and so ether channel summary. Now again you can see ether channel is working fine properly. No interface P10. We have removed the port channel 10. Okay, now again ether channel is working properly. So this is the requirement on local switch, that speed and duplex should be same. This is requirement of local switch. Like on switch number 1 you are bundling these two interface, so these two interface speed and duplex should match. Speed and duplex should match. Now let me discuss on both switches what is the requirement. Guys, on both switches there is requirement that should be same on both switch as well. like Ethernet standard. If I will talk about the link between switches is fast Ethernet link. So let's say the port which you are bundling on switch number 1 is fast Ethernet, and the port which you are bundling on switch number 2 is Ethernet. Then again your Ether channel will not work fine. So Ethernet standard should be same. Ethernet standard should be same. Then we cannot aggregate Ethernet and fast Ethernet link. Always keep in mind. After that, if links are trunk link, then encapsulation protocol should be same. Trunking encapsulation protocol. If you are using .1q or ISL, so that encapsulation protocol should be same. These are requirement. Encapsulation protocol. Encapsulation protocol, or we can say trunk encapsulation protocol. Trunk encapsulation protocol should be same. Then next requirement is VLAN allowed in list should be same. VLAN allowed in list should be same. Then native VLAN should be same. Native VLAN should be same. And if you have enabled the pruning, then pruning exhibitability list should be same. If you have configured the pruning, then pruning eligibility should be same on switches. Then only Ether channel will work properly. So these are the requirement of Ether channel. Okay, is any dot in this? Anyone have any dot in this? No. Method of Ether, method to form Ether channel. How many method we have to form Ether channel?
2.
2. Static
Dynamic.
and dynamic. In dynamic, how many protocol we have? 2.
Protocol.
PAGP
And LSCP.
and LSCP. We have 2 protocol in dynamic. LSCP, Ether channel static or dynamic configuration depends on the mode. In static, we have only one mode, that is on mode. If you are using on mode, that means you are configuring static Ether channel. If I will talk about PAGP, so in PAGP we have 2 modes. Can anyone tell me the name of those modes?
802.1q.
No.
ISL.
Wait. Let me discuss
Or
all one by one. First, static. Guys, in static we can bundle up to 8
8.
link. Up to 8 links. We can bundle up to 8 links. After that, mode of static is on. Then in dynamic we have 2 protocol, PAGP and LSCP. First let me talk about PAGP. This protocol is an Cisco proprietary protocol. Cisco proprietary. That means you can configure this protocol only on Cisco devices. On non-Cisco devices you cannot configure PAGP. And with the help of this PAGP protocol, we can again bundle up to 8 link. Up to 8 links can be bundled. After that, if I will talk about modes, so this protocol have 2 modes:
auto and dynamic.
desirable and auto.
Okay.
Guys, desirable is similar like DTP
VTP.
desirable DTP desirable mode. It will always initiate the ether channel negotiation, and auto will always wait for ether channel negotiation. Okay. Now last protocol is LACP. In LACP is open standard protocol. First of all, it is an open standard protocol. Open standard protocol means we can configure it on Cisco devices as well and on non-Cisco devices as well. We can bundle up to 16 links here. We can bundle up to 16 links. And if I will talk about mode, so we have two
Active,
modes again
passive,
here: active
passive.
and passive. Very good. Again, active is like desirable and passive is like auto. Active will always initiate the negotiation and passive will always wait for the negotiation. It can reply, but it cannot initiate. Passive cannot initiate the negotiation. Is it clear?
Yes,
We
sir.
have three method to configure ether channel: static and two method: static and dynamic. In dynamic we have two protocol, PAGP and LACP. In PAGP we can bundle up to 8 link, and PAGP is an Cisco proprietary protocol. LACP is an open standard and we can bundle up to 16 link there, and both have two modes. PAGP have desirable and auto mode, and LACP has active and passive mode. Active and desirable is like dynamic desirable. It will always start the initiation, and auto and passive will always wait for the negotiation. Now I have one question. Question is, if I can bundle up to 16 link in LACP or 8 link in PAGP and I have two switch. Let's say this is switch 1 and this is switch 2. In switch 1 and switch 2 we have some link. First of all, let me write here that this is switch 1 and this is switch 2, and here we have some link 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. If we will bundle the all link through LACP protocol, through LACP only we can bundle 16 link together. Let's say through LACP we have bundled these all link together. Now only 8 link will be in active state and 8 link will be in standby state. Means if active bill goes down, then standby port will become active. Only 8 link will be active at a time in LACP also. Even you can bundle 16 link, but only 8 link will be in active state. Okay. Now question is, which 8 links will be in active state and which links will be in standby state. Okay, because let's say here this port is port number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and here we have 16. How switch is going to decide which 8 link will be active? So that's why in LSCP only we have concept of LSCP port ID, because in PSEP if you are bundling 8 links, all link will be in active state. In auto mode also means on static method, on mode also we can bundle up to 8 link, and all link will be forwarding in forwarding state. But in case of LACP, if you can bundle up to 16 link, but only 8 links will be in forwarding state. So let's say you are bundling 8 link, sorry, 10 link. So 8 link will be will be in forwarding state, and 2 link will be in standby state. Now which switch will decide and which ports will be in active state and which ports will be in standby state? So that's why we have concept of LACP port ID. LACP port ID. Port ID only required in case of LACP protocol, and LACP port ID is combination of two things. Can anyone tell me about those things, guys? LACP port ID is combination of which two things? It is combination of priority plus plus interface ID. Interface ID. Priority plus interface ID. By default, priority on switch is, as you know, 32768. This is the by default priority, and interface ID. So if I will talk about LACP port ID of port number 1 will be what? 32768 plus 1. This interface will have LACP port ID, and the lower means port, first 8 lower ports will become active. Ports lower port ID, LACP lower port ID. Ports with LACP lower port ID will become active. So first 8 link will become active, and last 8 link will become standby. Why? Because first 8 links have lower LACP port ID. These ports have lower LACP port ID, right? So these 8 ports will be in active state, and these 8 ports will be in standby state. Now scenario can be different, like on switch number 2, let's say this is port number 16, then port number 1, then 16, after that 13, then 12, then 11, then 10, then 9, and 9, then 8, then 7, 6, 5, 4, 3, 2, 1. Here we have some mistake. I think this is 16, 14, 13, 12. This is again 15, 14. After that 13, then 12. This is port number 10. This is port number 11, then 10, then 9, 8, 7, 6, 5, 10, 9, 8, 7. Yeah, correct. This is 4. This is 3. This port is 2. and last port is 1, right? We have like this ports like this on switch number 2. So now switch 2, which ports will become active? On switch number 2, these ports should become active. These 8 ports should become active and these ports should become standby. On switch number 1, these should become active and these ports should become standby. Yes or no? Now active port of switch number 1 is connected with standby port of switch number 2, right? Data forwarding is not possible. Yes or no? Getting my point, guys? What I am trying to explain you here, that in LACP we can bundle up to 16 link, and out of 16 link 8 link will be forwarding state and 8 will be in standby state. Now how we will decide which port will be in standby state and which ports will be in forwarding state? For that we have a concept of LACP port ID. With the help of LACP port ID, we can identify the port which will have lower LACP port ID will become active, and the port which have not lower LACP port ID will become standby. Now question is, on switch number 1, port number 1 is connected with port number 16 of switch 2. So port number 16 of switch 2 should become standby and port number 1 of switch 1 should become active. So now active port is connected with a standby port. So data forwarding is not possible with this link. So that's why this is also one problem. So that's why we have concept of LACP system ID. We have concept of LACP system ID. LACP system ID. Now LACP system ID is again combination of two things. First thing is priority. Priority plus second thing is base MAC address. Base MAC address. Now let's say switch 1 base MAC address is 0A and switch 2 MAC address is 0B. 0B. So what will be the LACP system ID of switch 1, guys? 32768 plus 0A, and system ID of switch 2 will be 32768 plus 0B. Which switch have lower system ID?
0A.
0A means switch 1. So switch 1 will decide only which ports will be active and which ports will be in standby state. So according to switch 1, as you know, this port is in active state and this port in standby state. So switch 2 is not going to actually calculate the active port and standby ports. Only switch 1 will decide it. According to switch 1, switch 2 will also put these interfaces in forwarding state and these interfaces in standby state. Is it clear? So there is only two concepts, LACP system ID and LACP port ID. This is only in case of LACP protocol, because in LACP only 8 link will be in forwarding state and 8 link will be in standby state. Is it clear? Is it clear to all? Enable config T and do so run interface f1/0/19. I'm going to remove which command? This command. From interface range f1/0/19 to 20, I'm going to say no to this. Done. and no interface P20. In the same way on switch number 2 also, interface range F1/0/19 to 20 and no channel group 20 mode, leave the mode, no interface P20. Okay, so ether channel summary, I don't have any ether channel here. Okay, on switch number 1 and on switch number 2 and on switch number 1 also you can verify. So ether channel summary, I don't have any port channel. Fine. Now I am going to use any protocol to configure ether channel. Interface range F1/0/19 to 20 and then again command is group channel group number 20 and then mode. And if you will put question mark over here, you can see how many modes we have. First mode is active mode. Active mode means enable LACP protocol. Auto mode means enable PAGP protocol, and only for detected, for PAGP device detected. Means as I told you, auto mode is always wait for the negotiation, it cannot initiate the negotiation. Then desirable mode means enable PAGP, and on mode enable ether channel only without using any protocol, and passive mode means enable LACP only if LACP device is detected. Okay, so see, passive mode and auto mode. Auto mode is enable PAGP only if PAGP device is detected, and passive interface means enable LACP only if LACP device is detected. So if PAGP device will detect, then auto mode can form ether channel and passive mode can form ether channel by using LACP protocol. Okay. So let's say I want to use PAGP protocol. So here I can configure which mode, desirable and auto. I am going to use desirable mode here. Okay. So channel, creating a port, channel interface, port channel 10. Then on switch number 2, interface range F1/0/19 to 20 and channel group number is let's say 10 and mode. Here I am going to use which mode? PAGP auto mode, because on switch number 1 I have configured desirable. Here I am going to use auto. Okay, and see ether channel is working or not. Till then I am going to connect router as well. Interface F0/0, IP address is 10.1.1.1 255.255.255.0, and on switch number 2, sorry, router number 2, I am going to configure IP on fast Ethernet 0/1, because 0/1 of router 2 is connected with switch 2, and say IP address 10.1.1.2 255.255.255.0, and let me disable the routing as well, no IP routing. Okay, no IP routing. And here on switch you can check interface, so IP interface P10, so port channel is up, right? And so ether channel summary, here we are able to see P state means, guys, here you can see P means in port channel, P means it is in port channel, and this SU is capital SU. As I told you that U stand for again in use and S stand for layer 2. So layer 2 ether channel in use, port channel 10. The protocol which we are using is PAGP protocol, and here we are not able to see any mode. that which mode you have used to configure PHP protocol, right? But if you will run show ether channel and then what, let's say detail command or channel group number, that is 10, or we can say port channel 10, port channel 10, port channel, like this. We can check directly detailed information of interfaces. So ether channel detail. So you can see here we are using which protocol, PHP protocol. We can bundle how many link, 8 link, and layer state is layer 2 ether channel. This is layer 2 ether channel. And now on interfaces we can see the mode. Here also we are not able to see mode, which mode we have used. Here we can see the mode. What was the command? I'm missing.
Summary.
So ether channel summary.
So ether channel summary. Yes.
No, this command is not showing me the
Yes,
mode of ports. Summary.
protocol.
I want to check mode like port.
Show interface PO10. Show
Show
IP
running
interface
interface.
PO10.
I think
So
show running interface.
no, so running interface will not show you the mode. Here is the mode, na? Here is the mode. This is the command. Which mode we have used here? On 0/20 mode desirable, and on 0/19 also you can see mode is desirable, and on switch number 2 so ether channel port. Here we have used which mode? Automatic mode. Automatic mode. And ether channel is working fine. Router 1 can ping to router 2, ping 10.1.1.2. Why ping is not working? Because switch interfaces are down. Interface F1/0/1 no set. Switch number 2 interface F1/0/2 say no set. After 30 seconds router 1 can ping to router 2. After 30 seconds it can ping. So a spanning tree protocol. This port is now root port. Now you can see here from router number 1. Okay, so ping is working. That means ether channel is also working fine between switch 1 and switch 2. Now you want to check, let's say, which port switch 1 is using to forward traffic of router 1. What we can do here? We can first clear counter fast ethernet 1/0/19 and fast Ethernet 1/0/20. And after that we can check so interface F1/0/90 packets include packets output. Interface packets output. "24 packets have out from fast Ethernet 0/19, and let me check on this interface 20 14. Right here I am going to send 1000 ICMP packet to router number 2. Now we can check switch 1 have forward all packet from 0/20 interface. 0/20 interface. Getting my point? On 0/90 we have only 40 packet output count, and on 0/20 we have around 1020. That means all 1000 packet have out from which interface? Fast Ethernet 1/0/20. And if I will check input count, packet input, that when reply come input, when reply come, then here we have 1000 packet, and on fast Ethernet 1/0/19 how many packets we have? We have only 25 packets. That means when router 2 have sent traffic to router number 1, right? Router switch 1 have received traffic on 0/20 port, and when router 1 have sent packet to router 2, it have sent from 0/20. Guys, it depends on the load balancing algorithm. For now, if I will check MAC address, so interface F0/0 include, this is the MAC address of router 1 interface. It is performing load balancing on the basis of this MAC address, source MAC address. So source MAC address in last value is 8, and on router number 2, so interface F1/0/20 include, include, so interface fast Ethernet 1/0/20, interface F0/1 include interface, so interface, so interface this one, so in last value is 1. So actually, you know what switch is doing by default, the load balancing algorithm that is running on switch is source MAC address. So whenever router 2 will forward traffic, this is R2 and here I have R1. R1 last value in MAC address is 8, and here last value in MAC address is 1. So if you will convert this value in binary, so binary will be 0/0/0/1, and here binary will be 1/0/0/0, right? And it will use last bit, this bit, for the load balancing. So in maybe next class we will understand load balancing concept, how it is performing load balancing. But as you know, for now switch is using a single link from the multiple bundle link. That means there is definitely one pattern that switch is using to forward the traffic. So we will discuss about that pattern also. But here we have understand the PAGP configuration, right? PAGP configuration, and we can check protocol by running command this also. So ether channel, not here on switch number 1, so ether channel and protocol. So which protocol we are using? PAGP protocol. Okay, protocol, and after that question mark, there is no any more option. So ether channel, then put question mark. We have multiple option. We have already discussed this summary output. We have already discussed the protocol output. Then we can use port channel number, that is 10, and hit enter. Note like this. Here we can check port information, like we already check port information to check the modes or status of ether channel. Then we can use detail command. We can use here also protocol command and summary command. Okay, but here we have some more option like port and detail. You can use port after that detail also, and then port channel. So what is inside the port channel? Port channel. In port channel also output is similar, like so ether channel port details. Group number 10, port channel in the group is okay. Port channel group number 10. Then we have similar information like on interfaces. These are the mode. Through this command also we can check modes of interface. And so ether channel load balance. So this command is used to check load balancing algorithm which is configured on switch, that is source MAC address. So on the basis of source only it will perform load balancing. So what is the problem if it is performing source based load balancing, guys? Problem can be occur when, let's say, we have one switch over here, one switch number 2, and here we have LAN user. Here we have LAN user, and between switches we have some link, and we are using, let's say, LACP protocol. 4, 5, 6, 7, 8, 9, 10, 11. Let's say we have 11 ports. So out of these 11 ports, 8 ports will be in forwarding state. 2, 3, 4, 5, 6, 7, 8. These ports will be in forwarding state. Switches is going to use these 2 ports to forward traffic. Let's say here this is my switch 1, this is my switch 2, and switch 1 is connected with one router. Here I have one router, and this router is connected with, let's say, internet. This router is connected with internet, and my LAN user are accessing internet, right? There are lots of LAN user, lots of switches, right? Access switches are in the bottom, and all LAN user are accessing internet. So switch 1 and switch 2 will perform load balancing to forward traffic, right? Let's say this switch MAC address is 0A and this switch MAC address is 0B. So which switch have lower LACP system ID? Upper switch, switch 1. Switch 1 will become what? Master switch. So master switch will decide which 8 links will be in forwarding state, and which 8 links will be in forwarding state, the ports which will have lower LACP ID. So let's say these ports are in active state, and now switch 1 and switch 2 is performing load balancing. So here is one server, let's say 8.8.8.8. Whenever these machine will ping to 8.8.8, let's say here we have one computer whose MAC address is 00. So when this PC will forward traffic to 8.8.8, first it will forward traffic to switch 2. Switch 2 will check what? Source MAC address to perform load balancing, and then maybe it will use any one link between switch 1 and switch 2, and by using that link switch 2 will forward traffic to switch 1, and switch 1 will forward traffic to router will forward towards ISP, because we will have one default route over here, right? So when PC will forward traffic to 8.8.8, source MAC will be the MAC address of PC and destination MAC will be the MAC address of gateway every time. MAC address of gateway, that will be C. So when reply will come up, when 8.8.8 will forward the reply packet. So when reply packet will receive by router, and when router will forward it to PC, every time source MAC will be what? 0C. So switch one will use any one link. Let's say it is using one link for this PC. Now when second PC will forward traffic, here we have one more PC whose MAC address is, let's say, 11. So for this PC it is using, let's say, this link number or any link number, any other link number to forward the traffic. It will forward the traffic to switch will forward to router will forward to ISP. When ISP will generate reply, it will receive by router, and router will forward to this computer. In that packet also source MAC will be what? 0C. Every time when router will forward the reply packet to PCs, source MAC will be 0C only. So it will perform load balancing every time switch 1 is going to use this link to forward traffic from router to PCs. Yes or no? So here we don't have load balancing for the reply packet. We are performing load balancing only for the traffic which PCs are sending to internet. But the packet which is coming from internet to my LAN is coming from single link between switch. Yes or no? Is, is it clear? Is it clear, guys? Tell me. Here we have problem or not with source MAC address. Whenever load balancing algorithm is source MAC address, then we have problem. Yes or no? Problem is reply packet will be forwarded with only single link between switch 1 and switch 2, because in the reply every time source MAC will be 0C. So that's why we need to change load balancing algorithm over here in this scenario. So in next class we will understand load balancing algorithm. Okay, we have multiple types of load balancing algorithm. We will see how switches are performing load balancing algorithm, how switches are going to use the bits for load balancing algorithm, how many types of load balancing algorithm are there, and then maybe we will move to layer 3 ether channel. Okay, what is the default load balancing ratio? Everything we are going to discuss in next class. And today I am going to show you how to change load balancing algorithm. For that, here we can say port channel, then channel group number, port channel load balance, and then you can see how many algorithm we have. It depends on the platform of switches. On some platform you will see less number of option, on some platform of switches you will see large number of options here. So now we can configure destination IP based load balancing. We can use destination MAC based load balancing. We can use both source and destination based IP address load balancing algorithm. We can use source destination MAC address algorithm, source IP algorithm, and source MAC algorithm. Okay, and this is the by default source MAC address. So next class is also, guys, is going to be very interesting if all the concept of today class is clear to you. Today we have covered protocol